Let's talk about dividing rational expressions. Okay, remembering that a rational expression is just a big fraction. And in order to understand how to divide big fractions, first we're going to look at how to divide regular fractions. So let's look at this. 4 over 3 divided by 16 over 9. Now, see if you remember, how do I divide fractions? How do I divide fractions? And the answer is, I don't. I take the first one and I multiply times the reciprocal of the second one. Okay, so I don't divide fractions, I turn it into a multiplication problem. And now that it's a multiplication problem, I can reduce at multiplication. Right? So instead of having to multiply the numerators and the denominators and reduce afterward, I'll reduce right now. See anything that reduces? 3 goes into here once, 3 goes into here 3 times, 4 goes into here once, 4 goes into here 4 times. All right, now let's multiply. 1 times 3 is 3 over 1 times 4 is 4. Completely simplified. So let's take a look at dividing a rational expression. Now, how would I divide this rational expression by this rational expression? I don't. I will change it to a multiplication problem. So I'm going to rewrite this one just like it is, x squared plus x minus 2 over x squared plus 8x plus 12. And I'm going to multiply it times the reciprocal of this one. Okay, so the reciprocal is x squared minus 2x minus 15 over x squared plus 2x minus 3. Okay, now let's reduce at multiplication. In order to do that, I need to factor all 4 of these trinomials. Okay, so if you need some help with factoring, you might want to go back and look at how to factor a trinomial. Now, these are all the easy ones. See, they all start with a 1. Leading coefficient is a 1. So I can pretty much go to straight to my binomials for all 4 of these. Okay, so let's see. What are we going to have? X and x, 2 and 1. It's going to be x plus 2, x minus 1. This one down here is going to be x and x. Let's see, multiply to get it 12. It's going to be 2 and 6. Multiply to get 12, add to get 8. All right, let's factor this one up here. We're going to have an x and an x, a 5 and a 3. 5 times 3 is 15. Negative 5 plus 3 gives me the negative 2. And then here we have an x and an x, a 3 and a 1, plus 3 and a minus 1. Okay, now it's time to cancel out. Let's see. Anything in the numerator will cancel with anything in the denominator. Reduce at multiplication. And what do you see? Oh, here's an x minus 1. That'll cancel out. Anything else? Oh, x plus 3. Yep. Nice. Oh, x plus 2. Nice. All right, what are we left with? Well, we're going to have, in the numerator, will be an x minus 5. And in the denominator will be an x plus 6.